Welcome class back to Chapter 9, Classes of your Python Crash Course textbook. This is your third lecture video, and we're going to look at the objective of inheritance. So you don't always have to start from scratch when writing a class. If the class you're writing is a specialized version of another class you wrote, you can use inheritance. When one class inherits from another, it takes on the attributes and methods of the first class. The original class is called the parent class, and the new class is the child class. The child class can inherit any or all of the attributes and methods of its parent class, but it's also free to define new attributes and methods of its own. So we're going to create a new file called electriccar.py, and what we're going to place in that is our car class. So I want you to take all of the car class, so you can go ahead and copy this information, and then I want you to place it in the new file called electriccar. Okay, so I have all of that right here. Okay, place it in there, call it electric_car.py. From there, you're going to go ahead and add the child class of electric car. In the parentheses, you're going to put the parent class name. So now it says electric car is the child of a parent class called car. Okay, and it's going to inherit everything that is defined in that car class. So all of these attributes it inherits, it can use, and the 4 methods that have been defined here as well. Okay, from there it has its own initialization function, okay, where we're going to use the function super. Okay, and super is a special function that allows you to call a method, okay, from a parent class. This line tells Python to call the initialization method from car, which gives an electric car instance all the attributes defined in that method. The name super comes from a convention of calling the parent class and a superclass and the child class a subclass. So I want you to notice here that when we are using super and when you're using initialization, that we're using the same parameters of make, model, and year that are up here, make, model, and year. And you have coded super before. Super has been coded in Alien Invasion. So when we run this, we have an instance called my Tesla. Okay, we send along, we have make, model, and year, okay, for electric car. And notice here in this statement it says get descriptive name. Well, get descriptive name is not a method of electric car, but it is a method of car. Okay, so by using super, okay, also using the fact that we're using the parent class here as a parameter for the electric car definition, we can use get descriptive name. So let's go ahead and run. Okay, and now we have 2019 Tesla Model S. Okay, defining attributes and methods for the child class. So now we're going to add in its own attribute of battery underscore size because it's an electric car. And then we're going to add in the method describe underscore battery. Now any attribute or method that could belong to any car should be added to the car class. So we'll come here into our code and we're going to go ahead and add in our new attribute of battery underscore size, and we'll say 75, and then we're going to go ahead and define the new function of describe battery. Okay, so we'll go ahead and give it a run. We have line 44 that is going to call describe battery. Okay, so this car has a 75 kilowatt battery. So that is adding in our own attribute for the child class and creating a method. You can override methods from the parent class, and you simply just define a method with the same name in your child class if you want to override the functionality from the parent class. Instances as attributes. Okay, so this one is the kind of the tricky section of this particular video. So we're going to go ahead and create a new class called battery. Battery is going to have its own initialization function as well as the describe battery. So essentially what we're going to do is we're going to take the information or the method from our electric car class and we're going to place this inside a battery. So let's go ahead and do that process in our code. Okay, so I'm going to create the class right before electric car. I'm going to call it battery. Okay, and give it its doc string. Okay, we're going to define its init function. Okay, and we got a little different syntax than what VS Code is popping up here. Okay, so self dot battery underscore size equal battery underscore size. Okay, so I need to add this up here as the default. No spaces. Okay, and then I'm going to take describe battery and I'm going to cut it, okay, from the electric car class, and I'm going to place it in here for battery itself. Okay, and make sure that the indentation comes correctly for that. So now the class of battery, okay, has its own initialization. It has an attribute called battery size. Okay, by default it's getting 75, and then the describe battery would go ahead and print that information out. Okay, so what we need to do differently for electric car, the child class, okay, is say self dot battery, okay, equals the battery class itself. Okay, so we are essentially assigning an entire class to the attribute here, in this case battery. So when we do that, we have to prefix our method, okay, here with the attribute itself. So my Tesla.battery, then describe battery. So we have to prefix it, okay, with this attribute, okay, when we are using this type of addition, okay, to a value for the value of battery. Okay, that's just exactly what you have to do in order for it to function correctly. So let's go ahead and run this and see if we get the same information. Okay, and we do. This car has a 75 kilowatt battery. Okay, so just to review this, okay, this is adding an instance, okay, an instance as an attribute. So we are essentially assigning the class, the entire class of battery, to this attribute. And when we do that, when we call methods, okay, call methods through the child class, in this case of electric car, we must prefix it with the attribute name itself. Next, we'll look at your lab for this section, and it's 9-6 ice cream stand. So an ice cream stand is a specific kind of restaurant. Write a class called ice cream stand, or a class, that inherits from the restaurant class you wrote in exercise 9-1 or 9-4. So you're going to take your 9-4, okay, and you're going to use that as your template here for 9-6. Okay, add an attribute called flavors that stores a list of ice cream flavors, and write a method that displays these flavors, and then create an instance of ice cream stand and call this method. So I am going to kind of just try to give you a little bit of a template, okay, for just the class ice cream stand, because I don't want to give you all the information for restaurant. Okay, so if we come back here, okay, and we use just car, right? So we're back here inside of car. I'm going to go ahead and remove all this information at the bottom. Now I want you to imagine at this point that this is your restaurant class, okay, and that is from 9-4. Okay, so here now you're going to create a new class called ice cream stand. And we know from this section that we're going to base it off of restaurant. Okay, so it's going to be a child class. Okay, and then we can say something like, in an attempt to represent an ice cream stand. Something like that. You can definitely, of course, change that up. Okay, then we're going to have its own function, right? Its own initialization function, init. So in this particular function, okay, you are trying to inherit, okay, you're inheriting from the parent class. So in this case, we need to have a name. So we are going to do self name, okay, and then that type. Now we're going to set the default type, because we're in an ice cream stand here, to say that our cuisine type is going to be ice cream. Okay, so within this initialization function, you're going to have your name and you're going to have type. The same thing that you had, okay, in your initialization function for restaurant. Here we're going to also have a method called flavors. Okay, now flavors, I want it to be an empty list. Now the reason I want it to be an empty list is because we don't want to assign, you know, strawberry, chocolate, and vanilla, okay, as our flavors. And unless, of course, you want them to be the default flavors. That's a totally different situation. Okay, but we're going to go here with an empty list. Then we're going to create a function called show flavors. Okay, and show flavors is just going to have just the self parameter. Okay, you come up with your own docstring. Make sure you fill that information. And then what you're going to do here is you're going to use a for statement. Okay, a for statement to loop through that list, right? So I'm just going to say use a looping structure to run through the list. Okay, let me put a comment in front of that. Okay, so that's what show flavors is going to do. Then you're going to create an instance, and whatever the instance name may be. Okay, so maybe it's the big one. I don't know, any name that you want to use. Okay, and you're going to base that off of your ice cream stand class. Okay, so ice cream, oh, jumped up there. Ice cream stand. Okay, and then you're going to go ahead and send along the name of your ice cream stand. Okay, so maybe it is the big one. Okay, then you're going to have to assign flavors to this list. So you created your instance, the big one. Okay, now you're going to have to add flavors, okay, to flavors here. So I'm just going to put in the comment, assign flavors to attribute of flavors. Okay, then the last part here is we're going to call show flavors. Okay, so that wraps up 9-6 lab. Okay, if you get stuck, just reach out, send me what you have, or we can meet through virtually as well if you have further questions. Thank you.